Hello everyone, Jeff of the Green Review here. The ability of a soil to provide the essential nutrients required for optimum plant growth is called the fertility of the soil. 16 chemical elements are considered essential for plant growth, but more than 50 are used by plants. Each is considered essential if normal growth can't happen without it and no other element can substitute for it. In order of the quantity used, we have the three non-mineral nutrients of carbon, hydrogen, and oxygen, then the primary nutrients of nitrogen, phosphorus, and potassium, followed by the secondary nutrients calcium, magnesium, and sulfur, and last we have the micronutrients boron, chlorine, copper, iron, manganese, molybdenum, and zinc. Even though we use these terms such as primary, secondary, and micro, all the nutrients are necessary, and if any of them are not available in sufficient quantities, plant growth will suffer. Plants have a preferred range of each nutrient where they will thrive. With deficient amounts or greater toxic amounts, there are ranges where they will survive, slowly die, or quickly die. Secondary nutrients are needed by plants in moderate amounts, while micronutrients are needed in small amounts. Most soils are not deficient in them. However, deficiencies may show up if the garden soil is too acidic or not acidic enough, or in soilless potting mixes. They're used in container gardens. Calcium is used in cell wall formation. Magnesium is in the center of the chlorophyll molecule, and sulfur is part of the structure of many protein molecules. Plants absorb carbon, hydrogen, and oxygen through the air and water, while the other nutrients are gathered from the soil for normal green plants. And a lot of plants, of course, are parasitic, and so that changes. Deficiencies in soil nutrients can be overcome with the addition of fertilizer, organic matter, nitrogen-fixing bacteria, and other means. The nutrients used by plants come from many sources, such as weathered bedrock, sediments, organic matter decomposition, the atmosphere, bacteria, fungi, and fertilizer. Every nutrient is constantly on the move through the ecosystem. For example, a mineral in a plant is eaten by an animal, the animal dies or leaves organic matter behind that is broken down by bacteria into free-floating minerals in the environment that are eventually absorbed back into a plant to start all over again. Nitrogen is used by plants as part of the chlorophyll molecule. It is used in all amino acids in plants and animals. It is part of protein and is part of DNA. The Earth's atmosphere is around 78% nitrogen, but in this form it is not available to plants or animals. Lightning strikes change nitrogen gas into nitrate that is washed out of the air with rain and is then available for plants to use. Nitrogen-fixing bacteria have an enzyme that can combine nitrogen gas with hydrogen and turn it into ammonia. Some of these bacteria live in the root nodules of legume plants, where they produce ammonia for the plant. In exchange, they receive carbohydrates and other chemicals. Legumes include peas, beans, soybeans, honey locusts, redbuds, and many other plants. All animals get their nitrogen from eating plants or eating plant eaters. Nitrate from lightning or from farmers injecting it moves through the soil because it is highly soluble in water. It can become a pollution problem when it gets into drinking water or in lakes and streams. High levels can harm people and encourage algae blooms. Besides being produced by bacteria, ammonia is a waste product of animals. It is produced in large quantities in industrial plants for use as a fertilizer. Ammonia is toxic to fish and other aquatic organisms. Bacteria in soil and water consume ammonia as food, releasing nitrite, which is consumed by other bacteria as food and released as nitrate. In low oxygen conditions, certain bacteria can consume nitrate and turn it back into nitrogen gas that is released back to the atmosphere. Nitrogen gas being turned into nitrate that washes onto our landscape is the main reason that lawns turn green after a rain in the summer. The water helps to revive the plant if it has been dry, but the nitrogen is used in the chlorophyll molecule, which is green. Lightning may be scary, but it's God's way of fertilizing plants. Phosphorus is used for energy storage and transfer. A deficiency of phosphorus shows up in a purpling color on leaf edges or stunted plants. It is immobile in soil, so it should be added to the root zone for best plant uptake. It is not lacking in many soils, so a soil test should be done before adding more. Soils cannot hold extra phosphorus continually, So once the soil is saturated with phosphorus, additional applications will wash away. These additional applications can pollute water and can also encourage algae blooms. Potassium is used in chloroplasts, enzyme activation, translocating sugars, and regulating water in the plant. A deficiency of potassium shows up in older leaves as a mottled yellow, and the edges may die, so it's hard sometimes to figure out because it looks a lot like other kinds of problems that plants have. And it's slowly mobile in soil. Phosphorus and the much more mobile nitrogen are both nutrients that promote algae growth. Limiting enforcement efforts to only one of them will not be entirely successful in preventing algae growth and eutrophication problems in lakes and streams. Reducing pollution in ponds and lakes starts with eliminating shoreline erosion. Then it must look at the whole watershed of landowners, not just those who have lakefront property. Finally, it must look at the nutrients in the sediments in the lake itself, as nutrients are continually recycled back into the water and the organisms living in the water. Eutrophication is the excess richness of nutrients in a body of water, frequently due to the runoff from the land, which causes dense growth of plant life and death of animal life from lack of oxygen. Since phosphorus is normally immobile in soil and doesn't naturally move to wetlands, it is often a limiting factor in aquatic ecosystem plant growth. When additional amounts are added to an aquatic habitat, single-celled organisms like algae have faster access to it than larger and prettier plants. Some municipalities have banned phosphorus from being applied to lawns because inappropriate use has polluted lakes and river waters. Properly applied, it does not quickly move into nearby wetland areas. Shoreline soil erosion is an important phosphorus source for lakes and rivers. Misapplication of fertilizer applied to sidewalks and driveways where it can wash directly into storm sewers and then into ponds and streams is also an important pollution source of nitrogen and phosphorus. Municipal water treatment plants are a major source of phosphorus pollution in rivers. A generalized plant is 45% oxygen, 44% carbon, 6% hydrogen, 2% nitrogen, 0.4% phosphorus, 1% potassium, 0.6% calcium, 0.3% magnesium, 0.5% sulfur, 0.005% boron, 0.01% chlorine, 0.001% copper, 0.02% iron, 0.05% manganese, 0.0001 molybdenum, and 0.01% zinc. Look at that list again and think of how few of these minerals come from the plant food fertilizer we apply. Organic fertilizers supply the micronutrients better than inorganic fertilizers, but the air, water, and soil supply most nutrients. So what's this mean to me? All of those chemicals and others, such as aluminum, cycle through plants and the environment. Plants only store chemical elements, such as carbon, for a short time. Decay organisms and decay release the chemicals back into the environment. This is Jeff for the Greener View. Thanks for watching.